Welcome back, geometry students. We are going to take one more look at lesson 5-7, the Polygon Sum Theorem. We started this with triangles, and then we expanded a little bit to finding the interior measures of other polygons that are different than triangles. And so I want to quickly remind you, we need to recall, first of all, how many different sides some of the other polygons have given their name. And so you might want to write these names down along the left-hand side, and we're going to talk about each one of them. A quadrilateral, hopefully you remember that a quad means 4, so quadrilaterals have 4. Pentagon has 5. What about hexagon? Should be 6. Nonagon, I'm going to skip down here to nonagon. Now that's 9, because an octagon is 8. Heptagon is 7. Decagon means a 10. And what about a dodecagon? Well, that is 12, right? That's 12. And so you might want to become familiar with those because we will use those names of shapes in different worksheets and even the test that's coming up. Now, the other part that we talked about last week, was a regular polygon. Right? The word regular implies that the polygon has all sides and angles congruent. All of them, both angles and both the sides. Occasionally, we can have an equilateral polygon, which means just the sides are congruent, or we can potentially have an equiangular, which means just the angles are congruent. But when we use the word regular, it means the angles are all congruent and the sides are all the same, which is what you get in those 4 diagrams. Now, last week I showed you a formula that'll help us find the interior measures, which then we can go and work backwards to find potentially an exterior. We're going to give you another option to help you find the exterior angles first, which then allows us to find the interior a little bit easier, okay? The interior angle and the exterior angles of a polygon form a linear pair. There's that justification and definition again, a linear pair, which means these two have to total 180 degrees. That's what we talked about last week, and we hopefully understood that. But here's the new part that I think might make things just a little simpler, maybe. The sum of all of the exterior angles of any polygon has to be 360. So that one plus that one plus that one plus that one plus that one. If I draw them all in the same direction. So those 5 are all going to be the same and they have to be 360. So we can calculate them by doing 360 divided by n, or the number of sides or the number of angles that are going to be around the inside and outside. Okay? And that's the best part, is now we can create this shortcut. So let's look at this example of a pentagon. Find the measure of an interior angle of the regular polygon. So we want to find an interior one. The best way to do this, or the most efficient, it's another way, is to recognize there's going to be 1, 2, 3, 4, 5 sides and 5 angles. So I am going to take 360 and divide that by 5. That gives us a value of 102. I'm sorry, it's not 2. 112. 112. Okay. This will give you the measure of an exterior angle. 112 degrees. My math is just horrible, isn't it, today? See, even a math teacher makes mistakes. It's not 112. I don't know where I'm getting that number from. My goodness. It should be 72, right? 5 goes into 36 7 times. We are left with 5, 1. So it should be, I am so sorry, it should be 72. And hopefully somebody was yelling at me through the computer. 72, right? So that means one of these exterior angles is 72 degrees. 360 divided by the number of sides. Now, the best part is we didn't even do any formulas. We just found the exterior angle. If we remember, this angle and that 72 have to total 180 degrees, which means if I do 180, take away that 72, we're left with 108. This interior angle would have to be 108, which means all of them would have to be 108 because it is a regular pentagon. 108, 108, all the way around. So hopefully you can see that by taking the number of sides, as long as we know that it's regular, take 360 divided by the number of sides to get the exterior angle, and then use that to find the interior. Now, I want you to try it on this one. Pause the video and see if you can find an exterior angle and an interior angle of a nonagon. All right, so hopefully you took a moment to try that. A nonagon is 9 sides. If it's got 9 sides, that means we can do 360 divided by 9, which is 40. 360 divided by 9 is 40. That means one exterior angle is 40 degrees. One exterior angle is 40 degrees. So if I were to try and draw a nonagon, and I'm not going to be very good at this because it needs 9 sides and they're all equal, but you get the idea, I think. Right? That would mean this down here is 40. What does that make the inside one if they have to be 180 together? That means the interior would have a value of 140 for the interior. 140. So it's just a different approach to finding the interior and exterior angle measures of these regular polygons. If you have questions, please make sure that you reach out. We do have a test coming up this week on Thursday, and I want to make sure that you are prepared. Otherwise, until next time, folks, stay safe.